So what have we done here? We have obtained fx equal to summation of dn sine n pi by lx. And to solve dn, what have we done? We have multiplied both sides of this equation by sine m pi by lx, and then we integrated the term between limits from 0 to L, and we have obtained this expression. 0 to L integration fx sine m pi by lx dx. This is equal to summation n from 1 to infinity dn integration of this sine n pi by L sine n pi by L. And when we perform this integration, this integration will turn out to be simply L by 2 Kronecker delta n m. This will turn out to be L by 2 Kronecker delta n m. So this should be equal to summation from n equal to 1 to infinity dn L by 2 Kronecker n m. And when what is the value of Kronecker delta? When n is equal to m, this is equal to 1. And when n is not equal to m, Kronecker delta is 0. So when I perform this summation, when n and m are not equal, we get 0, 0, 0, 0. And ultimately, when n and m are equal, we get 1 here. So final answer here is dm times L by 2. So this dn becomes dm, because only when n is equal to m, this is 1, otherwise this is 0. Okay, so let me take another sheet of paper. So this integration is equal to dm times L by 2. Therefore, dm, you keep dm here and take L by 2 towards the left hand side. So what do we get? We get, therefore, dm is equal to 2 by L integration from 0 to L, this fx, f of x sine m pi by L x dx. Okay. This can also be written as, so we can replace m by n. So m is any integer from 1 to infinity. Yeah. So we can replace m by n here, or the n equal to 2 by L from 0 to L fx sine n pi by Lx dx. This we can call equation number 17. Okay, this is fine. Here I have simply replaced m by n, because m and n, they simply mean that they are simply indices and they can take values from 1 to infinity. So m from 1 to infinity is the same as n from 1 to infinity. So I have simply replaced m by n. Now I'm going to substitute this value of, so I'm going to substitute this value of dn in equation number 15. Okay, so when I substitute that value of dn in equation number 15, we get the general solution for u. So substituting this value of dn in equation 15, we get u is equal to summation n from 0 to infinity. Sorry, n from 1 to infinity. This is not 0. This is 1 to infinity And whatever we obtain for dm here, dm is this. So this is 2 by L integration 0 to L fx sine n pi by Lx dx multiplied by these two terms, sine n pi by Lx e to the power minus n pi by Ly. So multiplied by sine n pi by Lx e to the power minus n pi by Ly. Okay, this gives the required temperature distribution in the thin plate. That is, this is the expression for the temperature distribution in the thin plate, and this is the final answer that we obtain. So I can stop recording now.